Before I start the talk, I loved coming to Israel and I learn every time something new. So for me, it was really new to be in December in Israel. So what I learned very quickly is rain. Yes, it rains a lot. So I'm guessing now why you built an ark and all this stuff, because the rain is really, really much. And I understood also that rain and Israel, it's complicated. So it's really something you can really shut down a whole country when it rains. So I had a talk at AWS user group a couple of days and everybody was worried that nobody will show up. And yeah, I'm trying to learn also Hebrew with my teacher and all this stuff, but I'm a little bit baishan, so I'm not going to speak now in Hebrew and I want to spare you my horrible pronunciation. Okay, platform engineering. That's part of the thing you will see here. And what I also liked very much that when you were at the talk just before of Asaf, Toda le Asaf, he prepared already some pieces we're going to discover also here. So VLLM has an important part here because, yeah, it's something where we're going to run stuff. So platform engineering. This is something you probably saw. And I will make a very quick run through the term platform engineering so you have a little bit of context and understand. I put my phone away because my wife always calls during talks. And this is something you probably saw when you're working, be it as a developer, DevOps engineer, or something like this. You have some kind of delivery chain where you have a security team, everybody works on its own, you have maybe a CI/CD pipeline in place and all the stuff, everything works on this one. And then comes all the time here this famous CNCF landscape. Now they branched also out for some AI foundation, but yeah, you see a lot of tools, so which tool to use, what to do. This is the place, why is it not clicking? And then you have also different teams, you know, you have one team working with a serverless application, another one on Kubernetes, someone on-prem, you see a lot of stuff going on. And now take a person from one team into another one, or you want to align, you want to apply security best practices through the whole company, it's get complicated. And I'm not talking always about startups or this kind of things where they can really overnight shift maybe the architecture with a lot of work. I'm talking here about enterprises. I'm from Germany, working for several German enterprises. They are slow. This is really something sure. And here comes now the whole platform idea into play to say, okay, let's start to build a platform with services. You see the people in the bottom, platform engineering team, mostly of people they are told to do this now, like, hey, you are now platform engineering. And then, of course, treating our internal developers are treating the persons inside the company as our customers, expose them services, the whole infrastructure as product thinking. So that's all the stuff coming in, and then you deliver the best breed selection of tools for them, and they can just take these so-called golden paths, consume them, and run. Perfectly fine. So yeah, platform engineering, practice of building and operating a common platform and so on. I have the tendency to always spoil my next slide. I don't know why, but so yeah, that's the thing. Okay. And of course, stuff has benefits. We're not just doing it for our CV and all the stuff. We want also to have some benefits. So of course, toil, reduction of toil, improve engineering productivity, which is very important and is always top of mind. And then here, provide a consistency, confidence, that's very good. And the last one, you never go wrong when you create a slide with scale, because everybody wants to scale. So you can say, I'm here because I'm helping to scale teams. Okay. Okay, so now to my talk. So I made the preparation. You should be a little bit aware about the part with platform engineering. So now, what is AI platform engineering and why you should care? So we see AI joins our life, the conference, everybody see interesting talks here. Shortly to my credentials, yeah, Engin Diri. I'm from Germany. I'm working for Pulumi, which is an infrastructure as code company, as a solutions architect. The senior I just add because I worked hard to get the senior, so that's something. And I set the scene with platform engineering. Now I have to set the scene also with AI and everybody here. And this is the easy part because you're in an AI conference. Things are changing very quickly in AI. So I put here this picture from Interstellar when they were on this, I think, Miller planet or something like this. Yeah, 1 hour here is like 7 years on Earth. And this is the same with AI. Things evolving very quick. And you know probably this one here. So this was, I think last week it was up to date. 2 weeks ago, I would say the today you are here was at Gemini 3. Then it was Opus 4.5. And yeah, this is also now old story. And now we have again OpenAI with GPT 5.2. Doesn't mean it's better or not, but it's just the circle it's going. I'm still using Opus for all my software development stuff. So that's something. I added this one spontaneously because I was, as I said, at the AWS user group and people are like, Engin, who are you? What are you doing? What are you telling? So Pulumi, very short, infrastructure as code, similar to Terraform or other providers. You probably worked. One of the highlights is that you can use familiar languages and tools. I will come to this. Works with any major cloud provider, which is very important. Open source. That's very important. We know with all the license changes that people don't like this. And of course, this is the part my wife and my daughter say, can you talk a little bit more about this? Because we want to have Lechem and we want to have Kesef. So that's the part they always push me. But yeah, I'm an engineer, so it's open source. You don't pay me. So why Pulumi? So we have agents on one side. And here comes the part. Agents are written in Python already. And here comes the next one. You can use infrastructure as code also written in Python. There's a Python SDK. You can provision your resources, and that makes the story very round, especially now in the AI world where people create, using different AI frameworks, they create their multi-agent, whatever setups, and then they can just continue deploy to Bedrock Agent Core and whatever. So using this stuff. That's done. Now we talked about the story time, so what I want to say, and this is also a very known phenomenon. You come with story time and then the audience is like, oh no, I'm not here to learn something about stories, but give me a second, I want to prepare the scene a little bit better and not too boring. Okay, so everything begins with a simple idea. It was the same for our customer. So everybody started to discover here AI and wanted to understand how they can use AI, because we all know, and this is something when you talk with your platform engineers, if you're not in the platform engineering team, the fear of shadow IT. This is something, if you want to scare your DevOps or your platform engineers with something, shadow IT, and say you have credentials for AWS console, and then they are completely in fear because you create something outside the approved way. And this is the same thing with AI. When the company is small, I talked about German companies, for example, developers find their way. They start working on this. And then you establish also something like a shadow AI where people use some kind of ragging with some frontier models and then just copy paste some secret documents or documents which should not be allowed to push somewhere. You know, all the time this confidential mark into some models, and then they just go for it because guess what? People want just to finish your work. And here's the same thing. People discover this is something we should really put on our radar and say, can we extend our existing platform with capabilities, with AI capabilities? Not like that the platform itself uses AI, but that the people are possible to order on a approved and sane way AI capabilities. And then, yeah, John Doe is like, great idea, because John Doe works, is my boss, and he's like, hey, that's fine. Okay, let's go ahead. Here comes the thing like, but why? You know, that's the question people are asking. Why would I want this? So here comes a point, and I'm talking again to set the scene on serving local LLMs. So it's not all about frontier models, which get served from a model provider, which, you know, like Claude or whatever, but also here like local. So where is it? Okay, so the primary one is to guarantee, that's the typical one, and I'm talking here really from the German Angst perspective to say, okay, we don't want that any information leaves our infrastructure. We don't want that some third parties, even if they say we are not training on your data, you don't want that maybe they are still training on your data and so on, because the moment you give up this stuff, you just have to rely on the trust me bro thing, and you don't want to do this. So here, eliminating this. Okay, something going on. And then, of course, regulatory compliance, you're obliged to some of the regulations in your country or in your working space. And then also air-gapped environments. I, as I said, worked for Kaufland Lidl. When you come to Germany, for example, they are similar to Carrefour here, what I saw, or AMPM. And then you have maybe factories where you want to deploy an agent. We had the thing in our cafe factory, which makes pictures of the cafe. And if it's not really nice, it gets automatically scraped. And this is some things where they don't have a connection in the factories. Okay, then strategic customization, frontier models are generalists. So this is something sure. I don't know why this is. Okay, then you want maybe to fine-tune. There was also a talk I attended about fine-tuning and giving here the power to smaller models and then make them as capable of frontier models. Uncensored logic, that's very interesting for cybersecurity firms because some of the models have some guardrails in and you cannot do this stuff, and so on and so on. Okay. So, continue the story. Created here our so-called golden path and say, hey, now you can deploy AI models on our Kubernetes cluster. And everybody, Sarah is very frenetic, like, wow, that's amazing. We always wanted this. But then reality hits. So you start getting messages from the people and then like, hey, I ordered a model and it's not working. I get deployment is stuck in pending what's going on. And then you find quickly out, and this happens in your local data center, for example, or if you use a cloud provider with a limitation that no GPUs are available anymore. And then you go to your Grafana dashboard and you find quickly out, hey, a lot of people provisioned models. Everybody get their own GPU, but the models itself, when you look on your NVIDIA dashboard, you see they are not 100% utilized. So there is something underutilized and idle lying around because people ordered it, played a little bit around, and as people are, they're like not touching it anymore. So Michael orders one, GPT-OSS, Jessica, and so on, and then again, things running around. And this is the last point, is something you see with, I always encountered with developers, resource hoarding. We have in German a phrase says, haben ist besser als brauchen. That means to have it is better than need it. So you just have it and one day you're like, hey, I have a model lying around. So resource hoarding is really a problem. And the only persons who are happy about this are, for example, NVIDIA, because they're like, they can sell you more GPUs and all this stuff. So they like resource hoarding. We don't like this so much. Okay, so this is a first approach we did very naively, you know, just going here, deploying here our model on one GPU, for example, and then having this way. And we take this and scrap it because this is not going to work. So we need a solution. Oh, yeah, that's me sitting together with our customers, you know, and our customers are much smarter than me, so they already figured some stuff out, and I try just to blend in what they come. So ideas we came up with to say, okay, what could we do? So let's increase auto-scaling of the nodes. That was one idea. It's a very legitimate idea. Set quotas in your cluster to prevent GPU overuse. And then also some more complicated stuff. Hey, there's the NVIDIA GPU controller. Can we not activate here some time slicing and then multi-instance GPU, the MIC, and so on and so on. So folks can order slices, of course, with a quota. And why this is not working neither? Yeah. If you increase auto-scaling, so what is the max of auto-scaling? We should still hit a number, a physical problem. Same goes here with quotas. Again, depending on the size of company, there are a lot of developer and or teams who are provisioning maybe multiple LLMs. And then also with the slices, so you know when you start to slice the stuff, the inference suffers on it. You know, it doesn't become as snappy as anymore, and people could still use multiple slices, which doesn't help us neither. Okay, but we also find out that there are some ideas we should definitely keep. So one of the ideas was we need to collect all the GPUs back again. That's not possible. We should not give one GPU to one team or, this kind of approaches. Another thing is, let's deploy each model only once. And we need some kind of API gateway in front of our AI to serve this stuff. And we need to give them a better way to access now these models. Is it me who's breathing all the time? Sorry. Again, now comes the point, we all know about this because this is something we did in our IaaS approach, infrastructure as a service. When we created our platform, we didn't say, hey, people get maybe a Kubernetes cluster for every project or whatever. Everybody gets a Kubernetes. We say, okay, we have maybe a managed one in different stages and people get access. OpenShift is completely built on this, that you get a namespace, tenancy by namespaces. So this is very well-known pattern. And let's put a label on it, and now we can call it MaaS, Model as a Service. So the new way, Model as a Service. So what we are going to do now to say, okay, let's give them access, API access for this, the pre-trained AI models we have running, or they want to train the specific AI model. And yeah, that's not something fancy. So yeah, it's logic to do this kind of stuff. So now reaching out again for the customers and say, hey, we have now a new way for this. So when Sarah comes and say, hey, I need access to Llama 3, whatever model, then you can just answer, say, hey, no need for this one. I already deployed this. It's already available. Go to our IDP, and then you can order this one. And if somebody comes up with a complete new model, then you can say, okay, let's work on this. Because again, we listen to our customers. We try to get the feedback and provide this as additional service. And then, yeah, before we had, I need my own model. And now we have, I need API access to the shared model. And then you can also do the whole announcement if something new happens, because what I mentioned before, infrastructure as a product. So when we have something new in place, we can simply announce it and tell what changed and so on and so on. So that's very good. And the Slack feedback is also like in reality. Okay, how does the architecture look like? So what did we cook? So yeah, that's me, coming up with some architecture for the people, because I'm working at Pulumi. Oops, sorry. Okay, so simple. In this case, on the left side, be it a CI system, be it a person or whatever, or a GitHub action, uses your infrastructure as code tool to spin up here in our AWS account here an EKS cluster. The speciality of this EKS cluster is we're going to use Carpenter, because now we can really spin up on-demand nodes. We can define nodes. Keep Carpenter in mind, because there is a plot twist at the end. And then we have our AI IDP, our light LLM, which is the gateway for AI. We have Kserve, which is serving here the inference. And then, of course, Jupyter Hub, because people want to access the Jupyter notebooks. So what is Kserve? There are a lot of tools out here, but here especially Kserve. It's a platform delivering you different pieces you can need for serving AI models locally. So let me click on here one. Oops, sorry. So we will focus here on the generative part. You have also a predictive thing. You have also a selection of best choices, what the team around, or the open source team around Kserve chose. So we see again what Asaf also talked just before, VLM as a choice as a supported runtime. For example, we have LLMD for splitting the workload on different GPUs. We have automatic scaling using, for example, KDA or Knative. We have here the gateway API, and as a base, we use Kubernetes, because that's the thing. So Kserve, in a short here, having here the possibilities to handle everything in Kubernetes and having access to Kubernetes native APIs, and then also here delivering here a unified interface for people to work on this. So that's Kserve. I don't know what my things. Good part with K-Serve is since September 2025, it's part of the CNCF, so you can be sure, okay, there is now the foundation behind this. It's not that something can happen to the tool. It's very difficult to pull out something out of the CNCF because it's donated. So you have the peace of mind when it comes to choosing a technology and say, okay, K-Serve makes absolutely sense. So it's an incubating project. And you will hear much more in the future about this. And then I talked about here about LLM, an open source Kubernetes native stack for distributing LLM interfaces at scale. Again, at scale, very important. And has also a lot of cool functionalities, and it's built in already, which makes it very, very cool. And you have here also some features like the key value cache aware routing, multiple accelerator support. We see that Google TPU and so on becomes also very powerful and very for people as an option to NVIDIA. VLLM just talked also about this. If you was in Asaf's talk, then you already know some stuff, how to tune VLM. You can do all the tuning also in K-Serve down to the runtime. You just heard from him. And it's, for me, it's one of the powerful runtimes here. So have a look also in this one. And it's, again, out of the box available. And here comes also the core part of K-Serve. We can define now different deployment types. We can say, hey, we have a single node workload. You define this. Interesting is for large models we want to deploy on our own infrastructure. You can now go to a multi-node workload setup and say, okay, I want to create a leader worker set where I have a worker, I have several, I have a leader and I have several workers. You can set this all up and it uses this pattern. And then also the disaggregated workload. I don't know, what is it? I'm not so smart on this one. Okay, but there's also problems, and I also want to share the problems. So everything is happy, you install it, but there's also some downsides in this solution. And I would like to share this because it's not that easy, you know, how it sometimes appears, hey, I run this locally. So what was our biggest downside we discovered was the cold start problem. So we pulled our models from Hugging Face and then just downloaded it during startup time. And then you can guess Carpenter provisions a new node on demand because you deployed a new model. And then you get the situation that the node gets configured, gets provisioned and attached to our Kubernetes cluster. And now we need to pull from Hugging Face here the model down. And this adds really, really up to the latency, to the time the model is available. And here depends also the use case. Maybe you would like to have a situation where you want to scale to 0 with Knative, for example. Then a new request comes in, and then you again need to call Carpenter. Carpenter gets, hey, here's your node. And then you're like, okay, now I'm going to download the Hugging Face. That was really a problem, the cold start problem. We are not 100% solved it very good, so I have to be honest with you folks that there are still some questions open. What we went also with the approach of K-Serve, they have the so-called model car OCI. So we can create now an OCI, a container image where the model weights are already pre-baked into the container, already downloaded into it. So the container with the models already downloaded can be then mounted to a directory. So you don't need to do any external calls on time. You have it already in a separate process built. And yeah, and then you can leverage your existing container infrastructure, you know, Artifactory or whatever system or ECR to deliver the container to the Kubernetes cluster you're using. So that's very, very cool. And this is the benefits of using the OCI approach is then we have really, really quick startup times as the moment the model, the node is attached, it downloads the container and starts it. So we have a lower disk space usage because we don't need to, don't have redundant copies around, and enhanced performance. And what I said, it's completely compatible with K-Serve. It comes out of the box. Okay. That's one thing. And That's the process we used here, so we did not use something new. There was already an AWS project around this. Let me turn on the light. And here we're going to create now, because we use BottleRocket for our containers. So what we did is using this project, the project spin ups an EC2 on virtual machine and then creates the downloading process. So everything, the image gets downloaded, gets baked into the VM image. And what we then do, take a snapshot out of it. So that's very interesting, because everything gets downloaded, the image is ready to use, and then we snapshot this and tell Carpenter to not use a fresh VM and a fresh AMI. Use this specific AMI because we know there's already the containers pre-baked into it. So that's also fine. It's an own process running here in AWS code build, creating this stuff, pushing to our ECR, and that's completely fine. What we started also to look around is here this run AI model streamer to say, okay, is there a way that we could stream the weights into the GPU directly without going the intermediate way over our file storage and so on. Still investigating this stuff, so it looks very, very promising, but we need to understand how does it work. So that's something we would like to evaluate in the future. Another thing we tried out was the split inference here, saying, okay, we want a GPU, CPU offloading. First test worked nice. You know, we could run models which would normally exceed the GPU and push some stuff out into the CPU, into the normal memory. But it has some downtimes also. It's a higher latency, slower tokens, because yeah, this memory is really, really slower than your GPU memory. And then it's more complicated for tuning and operation complexity. So this is something to keep an eye on it and see if it makes sense to some models and offer it as a service. Light LLM, as I said, is our API gateway. Again, you can choose different API gateways. What it does, it allows us here authentication. Come on. Routing, so we can have a single entrance to the different models. Sorry. Does it work? Okay. Tracking, we can get the matrices out of the system. I don't know what happened here. I'm sorry. Okay, and then having here guardrails, chargeback, which is very important. We can put the costs people use, because we are renting the VMs depending, or have some costs, we can put them back. So chargeback is very important. And now, how does the AI IDP look like? So this is something we created on top of it to say we have a model library. You can discover which models are available. You see the price, you see the capabilities. You can create via API keys. You can create your API key. You see in the subscription. If I have time, I will show you quickly. And then you get also the FinOps dashboard. Okay, and let me give you a very quick look onto this. If things are working as it should. So as I mentioned, seeing here the models, you can have a look into this, which is very important. What are the capabilities for people to choose it? And then you can create your API key, what I mentioned, with self-service, creating an API key, getting access to the different models. You can see which models you are subscribed to, what costs it's already generated here. And most importantly, also you have here the FinOps capability to see how many calls did I make, what will cost. You have the complete breakdown of this. You can say, okay, let's create also a new API key, rotate this through. So a lot of self-service capability baked in. And the most interesting part was that you can create now also your Jupyter notebooks, which people love a lot, and can choose if I want to run it on a GPU node or if I want to run it on a CPU standard mode. Okay. So, we have 40 seconds, so let me finish the slides. Okay, there's the link, and feel free to join later. I can share the repository also. So results from several deployments, in this case here 10 deployments, we went down to 1 deployment. We reduced the GPUs needed on the specific case for the specific model, because not everybody has now its own. We have a cost reduction, and we increase the GPU utilization, which is the goal, to not have idle resources around. And as a wrap up, come on, go quickly through 0. So faster time to production, which is important. Why? And then reduced cost, which is very important. Something is broken here. Better governance, improved security. And yes, AI platform engineering is now enhancing our already existing thing with the new type of workload, following still our platform engineering principles: self-service, automated infrastructure management, standardized deployment patterns, and built-in governance. So we really fulfill, even with this new type of workload, our stuff. And I'm going to shut down now and say thank you. Wait. Thank you.